So for today, we are doing a final review, and we're going to take 2 days to review this stuff. And today actually is technically not all review. It's a lot of review, but I have one last thing to teach you. So I'm going to do a little review of the stuff that you're supposed to know already that leads to this, and then I'm going to teach you the new thing. Then tomorrow is all review, and then the test at this point is scheduled for Wednesday. All right? All right, so here's the first thing that I want to remind you about. If I have a function that's like 7x plus 5, can you tell me the inverse of that function? Hint, everything gets switched around. Headphone, sir? Thank you. When I say everything gets switched around, I mean like this used to be y equals 7x plus 5. Now it's x equals 7y plus 5. And then I subtract 5 and I solve for y. Go ahead and finish that. To keep me from intentionally picking on people over and over. This says I should call on Addie. So, what do you say? Just trying to solve this for y. Yep. X minus 5 equals 7y. Now what? Yep. And the final answer is that. X minus 5 over 7. Raise your hand if you had that one right. Cool. All right, now the next part is, what if they asked you for the domain and range of this? You might freak out a little bit because we haven't talked about domain and range in 4 days. Now I get it, it's hard to remember, but do you get that there's nothing on the bottom that you can change? There's no number that you can stick in on the bottom that would make this equal 0 on the bottom. Do you get that's a problem if your function has a 0 on the bottom? Does our function have a 0 on the bottom? No, so we don't have a problem there. Do you get there's also issues with square roots of negatives? Do you get you can't do that? Does this have either of those issues? No, so it has no restrictions, so the domain is all reals. But this is really important. It depends on what the original one's domain was, because this guy's domain affects the inverse. So does the original one have a domain of all reals? Yes, you can put in anything you want. You know why? Because there's no square root to make negative, and there's no way the denominator can become a 0. Because the denominator right now is just a 1. Okay, so this one's got a domain of all reals. That means it's that this one's domain actually is what it says. All right, here's another one that's a little more complicated. Y equals the square root of x minus 5. Does that have a domain? Well, everything has a domain. Does this have a restricted domain? Yes, because there's certain things that you can't put in. Figure out its domain. And then figure out its range. The only way you're going to be able to do that, at least if you're like me, is you're going to have to sketch it. Make a quick sketch. You'll know the domain and the range in about 5 seconds. If you don't know how to sketch this, you're going to get this one wrong. You got to know your basics. This is why I keep on pounding on that first 20, because pre-calc always comes back to little things. Like if you know what this looks like, it's no big deal. Look, square root, move to the right 5. Looks like that. And then that's the point. Why does that point matter? Because it'll tell me the domain and the range. That point is at 5, 0. And the things that kids mess up is they forget to graph it in the first place. And then they're like, I can't figure out the range. Once you graph it, it's not hard. It goes from 5 to infinity. And how about the range? Careful, not 5. 0 to infinity. All right. So please write those down right here. Domain, range. Turf, what was the domain again?
5 brackets, 5 infinity.
Yep. And the range?
0 bracket 0.
Yep. Now, I'm going to ask you to find the inverse of this function. And for its domain and range, don't even graph it. Once you find this inverse, just trust that these reverse. Because the domain and the range reverse just like x and y reverse. Tate, what's my new equation that I'm going to solve? Instead of y equals square root of x minus 5.
It'd be x cubed.
X, don't solve it, just tell me what to write.
Oh, x equals square root of 1.
There you go. Effie, you're trying to get x alone. So wait, trying to get y alone. So what are we going to do?
Square the third.
I agree, we're going to square it on both sides. And squared and square root cancel each other. These cancel each other out because they're inverses. And now our new equation is y minus 5 equals x squared. I think you know that you're just going to add 5 to both sides. And now y equals x squared plus 5. Raise your hand if you had that one right. Cool. That is your new function, and you might think that its domain would be able to be gotten from a picture. It cannot. This one's domain, since it was created by you from the original, its domain and range has to come from the original. Do you just copy them over? No, you reverse them. So the domain here becomes the range, 5 to infinity, and your domain comes from this range here, 0 to infinity. They're just the exact same thing as the original, except reversed. All right, so that brings us to the part where we have learned how to find inverses of functions. So now we're to our last thing. How do you prove that they are inverses? All right, I'm going to give you one. Here's 5x plus 3 is my original function. We're going to call it f of x. And then I'm going to give you another function called g of x. And think of it this way. Your friend says, I figured out the inverse. And the inverse of this thing was x minus 3 over 5. That's what they say it is. You have to prove if they're right or not. Now, you don't just go through that process that we just did. You do not do that. To prove something, it's complicated. That's what we have lawyers for, to prove stuff beyond a shadow of a doubt. Okay, so how do I prove these two are inverses? You can't just go through the process of making an inverse. That will not work. But here's how you prove it. And this I know is kind of a big deal because this is one of the types of questions they asked me when I had to pass national board tests on math. Is they had me prove that something was an inverse. So I thankfully knew that f of g of x is the first thing you find. You make the one function eat the other function. And you simplify it down. And it's going to end up simplifying all the way down. You'll see when you do it. So go ahead and do that. Make f eat g. You're supposed to know how to do that. Here's the f function. You write 5 with a parentheses where the x was. These parentheses are huge in this unit. But what does it eat? It eats the g, which is x minus 3 over 5. Now, the order that things cancel in are important. Right now, that minus 3 and that plus 3 can't combine. You might think they could, but you cannot cancel this minus 3 and this plus 3 because one has a denominator and the other doesn't. So the first thing you should do is cancel this 5 and this 5. Why? Because there's one on the top and there's one on the bottom and they cancel. Boing! then you have to show that that's simplified and rewrite it. You've probably heard this before. Math teachers are obsessed with showing your work. Because a lot of kids are just going to go, cancel, the answer's X. And it will be X. But you have to show me how that happened. The 5's canceled first. Now, do you see that the plus 3 and the minus 3 are obviously going to cancel? And I said it was going to simplify all the way. Look, it simplified all the way to just X. And that's what happens if you have really created two inverses. Unfortunately for you, there's two parts to the proof. And that is you have to do the other way. Like, yeah, we did f of g of x. Now we have to prove that g of f of x will also simplify all the way to x. You just saw me do that one. So start with the g function, make it have an empty spot where the x is, a parenthesis where the x is, and then drop in the other function, and I hope you see that it'll simplify all the way down to x. And that's how you prove two things are inverses. So here's the g function. And then I make an empty spot where the x is. And I make it eat the other function, which is right here. That goes in right there. 5x plus 3. Now, can the 5's cancel right this second? No. What cancels first? The 3's, because they're all on the same level, and if you don't know this, the top of the fraction has to be simplified first. If you have a giant fraction, the top of the fraction has to be simplified first. So these 3's will cancel, and I'm okay with you doing just like that. But then you have to rewrite it. It's going to be all about your work on this. I know it equals x. You got to prove it to me. And then you show me that now the 5's can cancel, so the answer is just x. See how they both simplified x? The first one came out to x, this one came out to x. That's how you prove two things are inverses. Now you do it. I basically did that whole thing. So here's one. F of x is 9x over 5. Would you please figure out if this really is its inverse? I think it is, but you'll be able to prove whether it's an inverse. So Noah, what do we have to prove again? That they're inverses, yes, but I mean, how do I do that? What do I do to prove that they're inverses? Yes. And simplify it all the way down. And I hope you know how to finish. So, I want to pause for a second and let everybody have a chance to see if they learned how to prove two things are inverses. Okay, so first you had to know how to take the f function, which is this one, make it have an empty spot where the x is, and then drop in the other one, 5x over 9. And then you had to know what cancels first. You remember me saying you had to do the top part of the fraction first? So what cancels first? The 9. Good. So then that cancels that. And then I rewrite it as 5x over x. And then, over 5. And then the 5's cancel and it equaled x. Yay. If you stopped right there, you lose because you can't prove it until you've done both ways. Lux, can you tell me the other thing I have to prove?
You also have to prove that g of f of x equals x.
Excellent. How many of you have already finished that? I don't want to waste your time. Okay, good. Nate, can you tell me if I'm going to take g, which starts this way, how do I do g of f of x?
You take the 9x over 5 and put that in the front.
Put that in. Perfect. 9x over 5. Can you tell me what cancels first?
The 5 one.
The 5's cancel first because you finished the top of the fraction first, and then you're left with 9x over 9, and that equals x. As long as you've proved g of f of x and f of g of x, the two things, both equal x, you've proved that this is a inverse. This and this are inverses of each other. That's what we just proved. Okay. All right, so inverse is like a big deal on your test. You've got to be able to, I give you a function, you have to be able to make an inverse. I give you a function, you have to know what its domain and range are so that you can reverse it for the inverse. We already practiced all that. And you have to prove things are inverses. What else is on your next test? Which could have been tomorrow, but we're giving you an extra day because this is a lot. To throw this on you on the review day would have been too much. So we're going to have another review day tomorrow and then the test. So what else do we have to know? Here's one. X squared. I couldn't believe how many people had trouble factoring this. I get it. It's a little weird. And then pretty much everybody should be able to factor that. Would you tell me the vertical asymptotes and the horizontal asymptotes? One of them, you use the 1000 trick. And if you can factor it, you should. I'm going to pause. Wait, try these. Okay, so this had a twist in it that I think confused some people. Right here. A lot of people get stumped, and would you agree that this is factoring? It is. How many of you factored it? Raise your hand if you were able to factor it. Only like 4 of you. All right, so this is again a basic. It's like, frustrating that it's algebra that's getting you, not the precalc. The precalc was knowing that you needed the verticals and the horizontals and that you have to factor it. Well, factoring is the skill that some of you didn't know. Now, how did I get that? I'm going to notice that there's an x in both of them. They both have an x. So I go, oh, so the GCF is an x. And I divide them both by x. What is x squared divided by x? It's x. What's x divided by x? It's 1. That's how I got that. Now, I know some of you need a little more time because you probably couldn't do the 1000 trick on this until you got it factored. So here it is. I'm helping because I know factoring, that is a really common weakness for kids is factoring, and it's the number one thing in this class. You got to know how to factor every weird kind of thing. Okay, now that that's factored, what part matters for the verticals? Is it the top or is it the bottom? That tells you the verticals. If you didn't know that, you should write that next to it because that'll help you remember it. The verticals come from the bottom. And that's two things then. X equals 5 and x equals negative 5 are the two things that make it 0. So those are the two asymptotes. X equals 5, x equals negative 5. Then you do the 1000 trick. I know some of you didn't have it factored, so you couldn't. Well, actually you could. It was way harder. So would you please do the 1000 trick here real quick and see what this thing is headed towards? Is it headed towards infinity, which would mean that there aren't any asymptotes? Is it headed towards, typically the other answers are 0 or 1. Sometimes the answer could even be 2 or 3 or 4, but usually the answers are y equals 1, y equals 0, or y equals infinity, which, is that an asymptote? Y equals infinity? Can you draw a line where infinity is? No. So you'd say there's no asymptote. Okay, here's the 1000 trick. And then if you're trying to say generally where is this headed, the plus 1 doesn't really matter. When you're talking about 1000 and 1000, you're timesing them. Holy cow. Plus 1 doesn't, or minus 1 doesn't matter, and these don't matter either. So that's really 1000 times 1000 over 1000 times 1000, and doesn't that all cancel? Then some kids are going to say, so it's y equals 0, because they're bad at math. And what is it actually? 1. And there's your answer, y equals 1. Now I want to show you another one. I'm going to write this in the right spot. Y equals 1. Do you remember me saying that there's horizontals are like the horizontal? The reason I'm concerned for some of you is you would have known the two answers are y equals 1 and x equals 5 and negative 5, but you wouldn't have known where to put them. The x ones, those are vertical asymptotes. I'm trying to connect the word vertical and the x equals kind. Okay, so you got done doing the 1000 trick and you got this. You got done with the 1000 trick and you got this. And you got done with the 1000 trick and you got this. Tell me the three asymptotes that means. If you just stuck in 1000 for x, that means you went way, way, way to the right on your function. That's really big picture what you're doing. You're saying, I'm going to go way to the right, so I'm going to put in 1000. And that means I went way to the right. And then the question is, where did you end up? If you end up with this, you didn't really want to stop at a hard stop of 1000, did you? No, this is like infinity. Because you could have put in infinity instead of 1000. So really, if you have a limit of y is infinity, you don't have a limit. This one has no asymptote. This one simplifies to 1, y equals 1. And this one simplifies to, is it really exactly 1/1000th? Does it stop right there? No. This is like infinity. It's like 1 over infinity, which is infinitely small, which is 0. So when the 1000 trick gets weird, if you end up with 1 over 1000, would you agree 1/1000th of the pizza, if you're sharing it with your friend, is like so small it pretty much is 0. And if you get 1000 of the pizza, you have pretty much got all of the pizza. So there is no limit. You got it all. So there's no limit when you get an answer like 1000. All right, so one last time. Would you tell me the vertical asymptotes and the horizontal asymptote on this one?
Hey folks, in this video,
Yeah, because it's over 2 1. Yeah. So fair.
Okay, if you haven't already, please compare, even if it's to say I'm lost.
X -5 is equal to 1 and then y equals 0.
X plus 6, x minus 6, and x plus 5 and x minus 1. First check to see if you factor it, right? Then the verticals come from the denominator here, and they tell me two things would cause a problem. X equals -5 causes a problem because you get 0. And what does that mean? That means you can't have a 0 on the bottom, so that must be a vertical asymptote. The other one's x equals 1. And the horizontal asymptote, we do the 1000 trick, because what we're trying to figure out is what happens if I go way over here. In the long run, you go way over here. Is it going to be like infinity, or is it going to stop somewhere? All right. So the horizontal trick, you just put in, to go way over here, we're putting in 1000. And then that means that +6 and -6 really don't matter. 1000 and 1000, and the +5 and the -1 really don't matter. And so that really means that all of these cancel, and it equals 1 over 1, which equals 1. So careful. If you just put a 1 here, I mark it wrong. Ava, what's the final answer for horizontal line?
None.
Nope. Everything canceled, and I got a 1.
Oh, so 1.
You just forgot the y equals. My point there is you have to say y equals. You can't just say 1. You have to say y equals 1. The horizontals are the horizontals. So that's all it was missing is 1. Because it was 1000 times 1000 over 1000 times 1000. They all cancel, you get a 1. I need to know, is this something that you guys get? So how many of you guys got that one right? Okay. All right. That's almost everybody. If you didn't get it, do you have any questions? Horizontals, verticals. You don't have to have it by tomorrow because the test isn't until Wednesday. But if you're lost, this is a good day to ask. So during work time today, make sure you ask me if you were lost on that. Okay, so we already proved whether something's a function or not by doing f of g of x had to equal x, and the other way around had to also equal x. But what was that other kind of proof? Claudia, we were saying?
Yeah,
Even and odd. Well, here's a function, and I'll tell you, it is for sure even. Can you prove it? Research says that it'd be better for me to see if you remember, because it stimulates your brain in a certain direction to be like, do I remember how to prove that? And if you don't, you'll listen better when I explain it. What if I give you the first step? I'm curious, how many of you remembered that before I said it? Only 5 people. You stick -x in. Sometimes weekends are like, wow, on how much you forget. I get it. I've been there. Weirdly, I've taught something and then forgot it over the weekend. Come back and been like, what did you do again? So, you're not alone. What did I do? I just stuck in a -x. And now you simplify it again. There's no way to simplify that, so I just keep copying it down. And this one, does the negative square away when you have something squared inside a parenthesis like that? Does it go away? Yes, it does go away, so it's just 2x squared. And then the fourth line is the proof line, and you were supposed to memorize these. It either equals f of x. Does anybody remember that, if that was the even or the odd proof? That was the even one. Or it equals -1 times f of x, and that's the odd proof. You have to write those down somewhere. You have to memorize them. You have to sit there in your room and stare at them until you remember that's the even one. If you write it down, it will improve the probabilities. You'll know it. And look, it starts exactly the same until it has a -1. And that's the odd one. And one of those two goes right here. So, you tell me, in our case, this one right here, this right here, is it f of x or is it negative of f of x? It's f of x. See, it's exactly the same as what we started with. So it's this one. So that tells you your answer. Was it even or odd? And there's the proof. you feel like you could do that? All right. So I'll give you a nice, easy baby proof that you should be able to do if you're new at this. Prove that this is not even. This is not going to come out to be even. It seems like it is because it's got the 2x squared, but prove this is not even. And by the way, some people think, oh, so it's odd? No. Just because I proved it's not even doesn't mean it's automatically odd. It is not odd either. Actually, it might be odd. No, it's not odd. I remember now. So, Bodhi, what do I stick in?
Negative x.
Correct. In both of the x's.
When it's odd, it's
Just wait. Next step isn't to decide if it's odd or even. The next step is to simplify. So don't jump a step. Spencer, please tell me what you got when you simplified it.
2x plus negative 3.
Wait, 2x, what?
Minus x.
Don't forget the squared. 2x squared minus x. You are correct. Now, is that exactly f of x? Is that the same as we started with? No, it's not. So f of negative x is not f of x. So this thing is not even. Because it didn't come out to f of x. If my only goal was to prove it's not even, I'm done. Because that, not the same as that, this thing is not even. All right, now I'm going to have you prove one's odd. This one, wait, I'm going to put a negative in front of it. Make it even a smidge more complicated, but still, I think, doable. Negative 8x to the third. Oh, wait, that's going to be just too much. Just take off the negative, sorry. Just erase the negative. Prove if that's odd. It looks like it's odd. I think it's odd. You move these off your ears? Thank you. I just need to know that you can hear me. So that is odd or even. I don't know. Let's find out. Stick in a negative x. Prove if this thing's odd or even or what is it? I think it's odd. Prove it. Put in negative x here. The third line is still, the left side is always just going to be f of negative x. From now on, it's always that. So then this is the simplify part. Does the negative stay with it? Yes, it does, but it moves out to the front. If you didn't know that, fix it. Because you don't want it to look like 8 minus x to the third. And the parentheses can go away. Because then it's easier to compare with the original. Is this exactly the same as the original? So then we can just skip right over. It's clearly not even. You guys should know that. It's not even then. So it must be, well, let's check and see if it's odd. Because if it's the same as negative 1 times f of x, is it? It is. Because it's negative 1 times this. So then it's odd. 4 lines to the proof. The first line is what they give you. The second line, you stick in negative x. The third line, you simplify. The fourth line is the only hard line. And that one is only hard because you have to know that two things, either f of negative x is negative f of x or it's regular f of x, and you have to now judge. And you look at it and you go, oh, I guess it's the opposite of what this was. So that one was an odd function. All right, we've covered about a little more than half of the test. So I'm going to hit you with the last couple things that you have to know for your test. And then you're going to have some time to work. All right. So here's the next kind that you have to know. If I give you two functions, f of x is x squared plus x, and g of x is x plus 4. Can you add them? Can you subtract them? Can you multiply them and divide them? We could ask you all 4 of these. We probably won't ask you all 4, probably ask you like 3 out of the 4. Can you add functions? Can you subtract functions? Can you multiply the functions? Can you divide functions? And here's my pro tip for you, and it's us obsessed with parentheses, Mr. Server. Yes. You know why? Because on one of these, if you don't have the parentheses, it's going to be wrong. In fact, on 2 of them, if you forgot the parentheses, it would be wrong. Well, I was just going to add them without the parentheses. Okay. And the add one, it really won't matter. There's a subtract, there's a multiply, and this one's divide. Okay. If on the subtract one, I made it really obvious. Look, you have to distribute that negative. That's the number one thing people forget. The add one should be easy peasy. X squared, and then you got a couple x's, so you say plus 2x plus 4. The next one, you had to distribute the negatives, and then your plus x and your minus x will cancel each other. The really common wrong answer is x squared plus 4. It's because that negative had to be distributed to both, so it was minus 4. Math rewards careful people. Then you multiply them. X squared plus x times x plus 4. Do you remember how to FOIL? Because if you don't, this is where that would bite you. You have to know every algebra trick that there is, because we're going to test you in this class. And if you don't remember things like how to multiply the firsts, x to the third, the outside plus 4x squared, the inside, x times x makes another x squared, and the lasts, which is plus 4x, and that these are like terms, so together they make plus 5x squared. You forget that kind of stuff, you're doomed in this class, because it's hard enough to remember the precalc, but if you can't do algebra, that's why there's still a few of you with 13 out of 20 on your basics. I'm not trying to look at anybody in particular, okay? There's still a few of you that kind of suck at this. That's going to keep biting you, because look, in one math problem, there's all these little algebra things, and if you don't know them, you must learn them. You've come to the part where you can't transfer out of this class anymore, so you need to learn them. So if I'm going to divide them, I like to write it like this. Now, some people mistakenly think you can cancel these x's. This was part of an add problem. I'll remind you, if I had 1 plus 4 over 4, could I cancel that and make the answer 1? No, 5/4 is not the same as 1. They're part of an add problem. When they're part of an add problem, you cannot cancel that kind. Those x's cannot cancel. So there's your final answer. X squared plus x over x plus 4. Okay, this one. X to the third plus 5x squared plus 4x. All right, now we didn't even deal with domain on these because the domain was all real for all of them. Like, until the very last one where we got this, do you get that one has a restriction? Everything except, what's the one thing you can't put in this function right here? -4. So the domain would have been everything except -4. Remember, the domain is what you can put in it. I can put in everything except empty spot right here I can't put in -4. Okay. All right, that's about as much as I think you can pay attention for. So this is the part where find the worksheet that is assigned for today. And I'm going to strongly recommend that you do kind of what I would consider the even problems from it. Why? Because you're not going to have to get all of it done. But we're going to work on it for 2 days. If you did the evens tonight and the odds tomorrow, then this is doable. So start on number 2 with me. In a moment, I'm going to ask you to turn it and show me that you're there, because there's a few kids that are just drifting, aren't actually in the worksheet yet. Find it. And if I'm just supposed to add them, oh, that's pretty easy. It is. Adding is the easiest kind. You just write the first one, and you write the second one, and then you can just add them. Why am I not putting parentheses? Because when you add something, you don't have to worry about distributing anything. Do you get on the subtract one? You'll want them in parentheses so that you don't by accident forget to distribute. When you multiply them, you just write the 2 things and put times in parentheses. Otherwise, let me just show you. If you didn't put parentheses here, you just write the 2 things times right next to each other. X squared minus x minus 1, and then you say times, and then you say the other function, -x plus 2. If you just wrote that, all it would get times is this right here. I think you know that's not what it means. You got to put them in parentheses so that you got a triple times a double. And once again, this is on the first 20, because some kids don't know how to do a triple times a double. And it's going to keep biting you in the butt. That's why I keep trying to help you catch up on your basics. I've done that first 20. I've assigned it 4 times, because things like this, if you don't know how to multiply this out, well, then you'd be stuck. And even though you understand the precalc, you don't understand the algebra. They say the same thing about calculus, by the way. The hard part of calculus is algebra. Once you're done with all that, you take the 2 and distribute it to everything. Then you go to number 4, and look, it asks you to do the domain for this. Remember, this one has a domain. This one has a domain. If I were you, I'd find the domains right out the gate. Because then, when you divide these 2, you have to consider all 3 domains all on one number line. So here's my f function. Here's my g function. And that is it. Remember that I said you couldn't break the ones in square roots? It's like they're in jail and you can't break them out of jail. You have to leave them there, so you can't simplify that anymore. That's it. That part's easy, but now what's the domain of it? You got to get its domain and both parent domains and put them all on one number line. All right, so if I were you, I'd do the even ones tonight. This was a very intense day, I get that. But if you're missing a lot of stuff, right now, this is not your last review. Tomorrow will be the last chance to learn this stuff, and then the test is Wednesday. Save yourself a retake, which takes 2 extra hours by studying between now and then. If you get stuck on these, look at the answer key. That's all I got for you for today.